Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder Chapter 12, multiple choice question number 24. The question says, three identical electric dipoles are arranged parallel to each other at equal separations as shown in the figure. The separation between the charges of a dipole is negligible as compared to the separation between the dipoles. In the given configuration, total electrostatic interaction energy of these dipoles is U0. Now one of the end dipole is gradually reversed. How much work is done by the electric forces? So we have to solve and see which option is correct. So let us solve it. Dipoles are identical, means its dipole moment P magnitude will be equal to P as shown in the diagram. All three dipoles are parallel to each other as shown in the figure and are located or separated by equal distance, that is r distance from each other. The separation between the charges of the dipole is negligible in comparison to the separation between the dipoles. So this separation is negligible in comparison to this gap or this separation. Total electrostatic interaction energy of this dipole in this arrangement is U0. It is given in the question. So we have to find when one end dipole is gradually reversed and how much work is done by the electrical forces for that. So for the convenience, this diagram has been made as you can see in figure 1. So if you follow the question, what is given is P1. If we say P1 is the dipole moment of 1 is equal to P, P2 is also P, P3 is also P. R12 is the vector between 1 and 2 and that is equal to R. R13 is this from here to here, that is 2R. R23 is from here to here, so this is R. From the formula, we know that the electrostatic interaction energy of two dipoles separated by a distance R is U is equal to 1 by 4 pi epsilon naught 1 by R cube. If R is the gap between that is given here, into P1 dot P2 minus 3 into P1 dot R into P2 dot R. Therefore, for this arrangement, we can write U0, that is given the total energy with this configuration. So U0 will be interaction energy between 1 and 2, 1 and 3, and 2 and 3, the sum of all these three. Let us say this as equation 1. Now we try to calculate the electrostatic interaction energy between 1 and 2 dipole, and we can use this formula. So we will be writing like this. P1 and R is perpendicular to each other because P1 is in this direction, R is in this direction. So P1 dot R will be 0 and P2 dot R will be 0. So similarly, P3 dot R will also be equal to 0. So what will happen? The equation 2 will reduce to U12. This part will be 0. So we can write 1 by 4 pi epsilon naught 1 by RQ into P1 dot P2. But P1 is P vector, P2 also is P vector. So that will become P square. Similarly for U23, between 2 and 3, 1 by 4 pi epsilon naught 1 by RQ into P square. And U13, only thing changing is the distance between 1 and 3, and that has become 2R now. So we can write this equation. Putting the value of U12, U13 and U23 in equation 1, we will be getting 17 by 32 pi epsilon naught 1 by RQ into P square. So let us say this equation as 3. So now the third dipole is reversed gradually. You can see here it has been reversed. The figure will change to figure 2 as shown below. So due to the reversal of end pole, that is third dipole, gradually the electrostatic interaction energy among the three dipole also be changed. So let us say that it has become U subscript F now. Therefore, U subscript F will be U1 and 2, electrostatic interaction energy between 1 and 2, because the dipole still is same with these two. But between 1 and 3 it has been changed. So we have written U1, U subscript 1 by 3 F. Same way between 2 and 3 also has changed. So we have written U2, 3 F. So U12 is this much. Now we will calculate for U13F and U23F. And let us say this equation 3. U13F will become 1 by 4 pi epsilon naught 1 by 2R, because the distance is 2R, ka whole cube into P1 dot P3. But now P3 has become minus P. So this will change, the sign will change, and text equation will become U13F is equal to minus 1 by 4 pi epsilon naught 1 by 2R whole cube into P square. Other comment you can give, negative sign has come up because the angle between 1 and 3 dipole being vector has changed to 180 degree, and cos 180 degree we know that minus 1. So similarly U23F you will be getting like this. Distance is R, so R cube. P square, only thing the sign will change, negative, because P2 and P3 are in opposite direction. So P2 dot P3 will be P minus P square because of angle being 180 degree. So putting this value of U13F and U23F in equation 3, we will be getting minus 1 by 32 pi epsilon naught 1 by RQ into P square. So this value we will be getting. So how much change in electrostatic interaction energy has occurred due to the reversal of dipole 3 gradually. So UF, that is U final minus U initial U naught. We will put the value of UF and U naught and solve it. So we will be getting minus 18 by 17 into 17 by 32 pi epsilon naught 1 by RQ into P square. But 17 by 32 pi epsilon naught into 1 by RQ into P square is equal to U naught. So we can replace that. So that will be minus 18 by 17 U naught. So this much energy will be spent by the external energy to bring this change. So electric force will be opposite to that external agency force. So the work done by the electric force will be negative of change in electrostatic energy. That is minus UF minus U naught. So it will become 18 by 17 U naught. If you see the option C is having this value. So answer C will be correct. Hope you understand the entire concept. In case any issue at any place, please do let me know through the comment. I will come back on it. Thank you.